Let's continue talking about molecules that have chiral centers and determine the absolute configuration and the relationship between molecules. So I have drawn here one molecule that actually has two chiral centers. We see here that the carbon that has a chlorine has attached one chlorine, then all this chain, then a metal and a hydrogen that's not pictured, but it's there. We know that, right? Then we have another chiral center, and I'm just going to box it. One chiral center and another chiral center. At this chiral center, you have now this chain towards the side, then an ethyl and a metal and a hydrogen. So 4 different substituents. It's clear that the molecule has two chiral centers. Now let's name it. And so we're going to say carbon 1, 2, 3, 4, and 5. So the molecule is 2-chloro, 3-methyl, and pentane. And to complete the name, we need to add the absolute configuration at the chiral center. For that, we're going to assign priorities as we have done before. So let's say priority 1 is chlorine. Notice that I'm using a different set of numbers. In this time, I'm using the circles. So for the second priority, the carbon number 1 is attached to 3 hydrogens. However, carbon number 3 is bonded, so let's put here a little arrow. It's bonded to carbon 4 into that metal. So it has 2 bonds to carbon and 1 to hydrogen. Whereas carbon number 1 has 3 bonds to hydrogen. Therefore, when I'm assigning my priorities, I know that there is a hydrogen in the back. I'm not going to draw it, but we know it's there. But so we have between the chain here to carbon 3 and 1, this side has higher priority because of this connectivity. So I am going to assign then priority 2 to the side, and again, other set of numbers with circles. And priority 3 is this one. Now, since I'm looking at that the right way with the hydrogen away from my view, I'm going to follow that sequence, and I'm going to say 1, then 2 right here, and 3. So this has the R configuration. I'm looking at that the right way. Okay, so that's a complete name. So R2-chloro 3-methyl pentane. No, it's not complete yet. Not. And why is that? Because we have two chiral centers. So now what I'm going to do is, yes, we have determined the configuration of one chiral center, and we need to do this. So now carbon 2 is R, but we have another chiral center, and that's carbon 3, and we have not finished the name until we have determined the absolute configuration of that. So here, let's use again, at carbon 3, which is my other chiral center, we see that assigning priorities is to the squeaker. This has attached hydrogen, hydrogen, hydrogen. There is a hydrogen in the back. And so comparing the highest priority group is either this side or that side, because again, this has attached 3 hydrogen. Now, carbon number 4 is attached to carbon 5 and 2 hydrogens, but carbon number 2 is attached to a chlorine in another carbon. So this has higher priority. Now, let's do the, I'm trying to find a way not to overlap so many numbers. So let's erase the previous, because I have a lot. So I'm just gonna redraw the lines, because right now I want to assign the priorities, but we're looking at carbon 3. So I'm gonna delete that. Let's remove that. Again, what I'm doing is I'm erasing, say, that extra information. You can do that in a separate drawing, of course, but as you get practice and practice, you don't need to draw as much. So I'm just cleaning this up a little bit to do the priorities on the other carbon 3, which is the one that we are assigning now the absolute configuration, and I need to redraw my chlorine. So I said then between these two, this side where the chlorine has higher priority, again, because chlorine has higher atomic number, so I'm gonna put a 2 here. Number 1, priority 1. Priority 2 will be this side, priority 3 is a metal, and the hydrogen is priority 4. Businesses behind, I'm looking at that the right way, and all I need to do now is follow the sequence. So I'm gonna say priority 1, priority 2, priority 3. I'm looking at that clockwise, that rotation, so it is R. So the second chiral center is also R. And let's do that in another color for the other center was 1, 2, and 3. So it is RR. All right. So let's do the enantiomer. And if we do the enantiomer, there's one easy way. Let's not do the mirror here. We know how to do the mirror. We learned in another video that when we did the mirror and compare that with the rotation, that for the enantiomer of this compound, there were 2 ways of drawing it. The mirror image was this, or we can just grab this one and do one switch here. And this too is the same thing. So this is equivalent to that. So all we need to do is to invert the configuration at the chiral center. So I'm going to draw, say, the skeleton the same. And now I need to invert the configuration of carbon. This is 1, 2. And to invert it, all I need to do is switch places. The hydrogen and the chlorine. So remember that here the hydrogen wasn't attached, so now it's going to be here. I have inverted the configuration at that center, and now I need to invert the configuration of the other center. So in other words, if you have one chiral center, in the chiral molecule, then the enantiomer will have the opposite configuration. But when you do molecules that have more than one chiral center, every chiral center will be inverted. So here we have chiral centers number 2 and 3. So same thing here. And now we know we did this in another exercise. Since we did one switch here, the configuration of the carbon's chiral center number 2 is inverted. So instead of being R, it's going to be S. So it is 2S. And then also the configuration at carbon 3 is inverted. And we're going to say 3S. And everything else in the name is the same. So 2-chloro, 3-methyl pentane. Now, the relationship between these two molecules, they are enantiomers. Same as here. So again, we can draw enantiomers, drawing a mirror image, or we can simply do one switch here. Here I have switched hydrogen and chlorine. And this is exactly what I did above, but I needed to invert 2 chiral centers. Carbon number 2, I did one switch. Carbon number 3, I did another switch. We'll continue doing more of these.